Okay. Hi viewers, in this video we will solve example 5.6 from the book McConkey and Td Eastop. So here is the statement and the corresponding PU diagram is shown here on the right side. So in oil engine takes in air at 1.01 bar 20 centigrade. So the inlet pressure and temperature is given, and the maximum cycle pressure is also given, that is 69 bar, and the compressor ratio is 18 by 1. Calculate the air standard thermal efficiency we need to determine based on the dual combustion cycle. So the dual combustion cycles here I already given there. Assume that the heat is added at a constant volume is equal to the heat added at a constant pressure. So here is the conditions given, that the heat that is supplied at a constant pressure process and at a constant volume process, that is same. So both at both process 2 to 3 and 3 to 4, same heat is supplied. So we call this as a Q1. So sum of this heat that is supplied at 3 to 4 and 3 to 2 is equal to Q1, and the heat that is rejected, that is from process 5 to 1 at a constant volume, that is Q2. So the volume at V4, that is equal to V1, and volume at V3, that is equal to V2, because that is a constant pressure process, constant, that is constant volume process. That's why its volume at point 2 to 3 and point 5 and 1 is the same, and same the volume at V3 and V2 is the same. And the pressure, that is the maximum pressure P3 and P4 is also same, that is given here, that is 69 bar, and the minimum pressure, that is 1.01 bar. Okay, let's solve this example. So the minimum pressure that is given, that is P1, 1.01 bar, and the maximum pressure, that is equal to P3, also equal to P4, that is 69 bar, and the minimum temperature, that is T1, 20 centigrade. If you convert that into Kelvin, just add 273 with it, it will become 293 Kelvin. Next, the compression ratio. So the compression ratio is the maximum volume and minimum volume, that is V1 by V2, and is equal to 18. So the next condition that is provided, assume that the heat added at a constant volume is equal to the heat added at a constant pressure. So the heat that is supplied here and there, that is same. So here I can write from process 2 to 3 is a constant volume process, so the heat that is supplied is T3 minus T2 is equal to Cp at a constant pressure, that is T4 minus T3. So on this provided data, we have to find the thermal efficiency. So we need to find the thermal efficiency. So here we begin the solution. As we know, the thermal efficiency is equal to the work done divided by heat supplied. So the work that is done is equal to the heat supplied difference. So the heat that is supplied minus the heat that is rejected divided by the heat that is supplied. So the work done is equal to the maximum heat supplied minus minimum heat rejected is equal to the work done. So thermal efficiency we can write in terms of heat is, here it is. So it will be look like this. Next, to find the thermal efficiency, what things we need to find? So to find the heat that is supplied is equal to CV. So 2 times heat is supplied, that is T3 minus T2 plus Cp, that is T4 minus T3, and the heat that is rejected, that is equal to Q2, that is equal to Cv, that heat rejection is taken place at a constant volume process. That's why we write Cv T5 minus T1. So from these formula we can clearly understand that to find the thermal efficiency it is necessary to find the temperatures T3, T2, the temperatures at every point should be determined first. So some temperatures are given and the temperatures that are not given we need to determine first to find its thermal efficiency. Let's move forward to V1 by V2 gamma minus 1, that is become 18 into 0.4, so it become, sorry, here I will write T2 divided by T1, maximum temperature to minimum temperature. Volume have inverse relation. So T2 divided by T1, that will become, so it was just simplify that on the calculator you will get its value 3.18. What is the T1 value? Multiply that with to find the T2 value. So 3.18 multiplied by T1, that is 293. So you will get the T2 temperature, that is 931 K. So next to find the temperatures, T3 temperatures, we know the pressure, we should know the pressures at P2. So the P2 divided by P1 is equal to P1 divided by V2 into gamma. So here it will become 18, that become 1.4. So after simplification you will get P2 divided by P1, that is 57.2. So the P2 value you will get, that is 57.2 multiplied by 1.1 bar. So you will get it value, that is, so this is the T2 value, remember. The P2 value is, now from process 2 to 3 there is a constant volume process, constant volume heat addition process, so the temperature and pressure have direct relationship. So I can write T3 divided by T2, that is equal to P3 divided by P2. So the T3 value will be equal to P3 divided by P2 multiplied by T2. So what is P3? That is the maximum pressure, 69. What is P2? That is determined here, that is 57.8 multiplied by T2, and T2 is 931. So you will find the T3 value, that is equal to 1112 Kelvin. This is the T3 value. So T2 is determined, T3 is now found, and uh, some temperature T1 is given. And now to find the temperature T4, we have provided the condition that heat that is supplied at a constant volume T3 minus T2 is equal to heat supplied at a constant pressure, that is CpT4 minus T3. So Cv is 0.718, that is T3 is 1112, minus T2 is 931 is equal to Cp 1.005, and T4 is unknown, that needs to be determined, and T3 value is 1112. So after doing simplification, you will find that the T4 divide both sides with 1.005, so you get 0.718 into 181 divided by 1.005. So if you transfer this value to that side, it will become in plus sign. So here this T4 will be equal to, after simplifications you will get its value is 1241.4 Kelvin. So all the temperature uh, is now is need to determine, so the only value that is left is T5. To find the T5 value, now what that is left, so what that is left is T5. To find the T5 value, we first know about the ratio of V5 by V4, right? V4 divided by V3, that is equal to T4 divided by T3. So T4 is 1241.4 divided by T3, that is 1112, and you will find in the ratio of V4 to V3, that is 1.116. But this value will help you to find the T5 value. To find its value, I can write V5 by V4 multiply and divide by V2. So this V5 is also equal to V1 divided by, so here I write in terms of V4, I can write V2 multiply by, so the in nominator V2 is left, and here I can write the V4. Now in terms of, so V1 by V2 in multiply by V2. V2 and V3 volume is the same. So in terms of this V2, I can write V3 divided by V4. So now put its value. V1 by V2 is the compression ratio that is given in the statement, that is 18, and V3 by V4 is the reciprocal of this value. So I can write 1 by 1.116. So after doing simplification, you will get its value, that is V5 by V4, that is equal to 16.14. So this final ratio of V4 by V5 by V4 will give you the value of T5. Now temperature T4, so the process 4 to 5 is isentropic process, isentropic expansion process. So apply the formula of isentropic equations. So here you can find V5 by V4 into gamma minus 1. So T4 by T5 equal to V4 by V5 is 16.14 into 0.4, and you will find its value after simplification, that is T4 by T5, that is equal to 3.04. To find the T5 value, just divide the T4 value, that is 1251 divided by 3.04, and you will get the T5 value, that is 408 Kelvin. Now all the temperatures at each point has been determined. Now the heat that is supplied is equal to CV into T3 minus T2 plus Cp into T4 minus T3. Just putting the values of each temperature, putting the corresponding values of the corresponding temperatures, you will get the heat supplied equation just like this. Now by simplification you will get the final value of the heat supplied, that is 260 kilojoule per kg, and the heat that is rejected is equal to Cv into T5 minus T1. So what is Cv? That is 0.718, and T5 is 408 minus, that is here you can see, and T1 that is 293. After doing the simplifications on calculator, you will get the heat rejected, that is 82.6 kilojoule per kg. The things are quite easy. The efficiency formula is equal to heat supplied minus heat rejected divided by heat supplied. So the heat that is supplied is 260 minus heat that is rejected is 82.6 divided by 260 that is supplied, and you will get, just solve this by in calculator, you will get its efficiency, that is 68.2%. Thank you so much for watching this example 5.6 video. More such videos from these books are on the way. Please subscribe my channel and share with your friends. Thank you.